My guest today is Steve Goreham.
Well, I want to talk about this huge trend going on in the U.S. and around the world, the artificial intelligence revolution and its impact on net zero, which is the goal to get to net zero emissions by 2050 that the world's been pushing for more than a decade. It is being challenged by the artificial intelligence revolution. So, what is the artificial intelligence revolution? This has happened fairly quickly. ChatGPT released their conversational artificial intelligence chatbot in November of 2022, only 3 years ago. And since then, the world of AI has exploded. ChatGPT showed that machines could learn the complexities of human language and interaction. After they released this chatbot, they had 1 million users in only 5 days. And now it's created just a tremendous change in the world. We have Amazon and Google and Meta and Microsoft and Tesla and other firms that are investing billions of dollars in data centers to run artificial intelligence. And this is directly challenging net zero. So let's go to the next chart and I'll talk a little bit about what net zero is. According to the International Energy Agency, reducing global carbon dioxide emissions to net zero by 2050 calls for nothing less than a complete transformation of how we produce, transport, and consume energy. And basically the idea here is to move away from coal, oil, and natural gas and toward wind, solar, and biofuels. And pretty much all the nations of the world have signed up for this. There are some people that are stepping back, as we'll discuss. But this is an idea that I write about in my latest book, Green Breakdown, The Coming Renewable Energy Failure. And Green Breakdown basically says the world's not going to get to net zero. And this is, I was making these conclusions prior to the AI revolution. So let's go on to the next chart here and talk about the AI revolution. I use a source called USA Data Centers. This is a map of data centers in the United States. Now, at the start of 2024, there were only 2,700 data centers in the U.S. Now there are over 4,000. We've got a 50% increase in less than 2 years, just an astonishing number. And data centers in the past would handle running the internet and grid storage. But with artificial intelligence, they need AI processing servers that can do these complex calculations. And when you upgrade the servers in a data center to run AI, you require 6 to 10 times more electricity than you did with traditional data centers. Now, at the start of 2024, data centers in the U.S. were using about 4% of our electrical power, but it's estimated that within a decade, that's going to go up to 20% of U.S. electricity, just a fantastic amount. And so all sorts of changes are in store. So one of the first things that's happening is that power plants are being extended or restarting all over the country. We have nuclear plants that are being restarted in Michigan, in Iowa, in Pennsylvania. They're also resuming construction on 2 plants in South Carolina. We have coal plants that were scheduled for closure to meet this net zero idea of reducing emissions. But those are now being extended all over the country: Tennessee, Utah, West Virginia, Georgia, Indiana, many other states. They're running coal plants longer and longer. They can't close them because they need the power. But the big winner is natural gas. There are over 200 new natural gas-fired power plants in planning or under construction around the country. Just a tremendous change. We had flat power for about 2 decades in the United States. And now there's a tremendous increase, and that's what's going on because of the AI revolution.
I do have a question, Steve. I think Apple was saying that our data centers are 100% powered by wind and sun, something like that. Do you think they're going to keep making that claim? I never believed it, but are they going to drop that claim?
Well, that is kind of strange too. And all of the big guys, Apple and Microsoft and Amazon and Google, all have these goals to get to net zero by 2030. But if you look at what's actually going on, they're not getting there. Microsoft, I think it was Microsoft, a couple months ago released or I think it was last fall, they released the figure that's saying that their emissions were up 40% in the last 5 years. So all these guys are going the wrong direction. And in this last year, the big guys in 2025, and again, this is Google, Meta, Microsoft, and Amazon are spending $360 billion in investment on data centers. And they've now announced plans for next year, and they're going to increase that number. These are just fantastic numbers. And so they need power for all these plants, not only to run them, but to cool them as well. And it's just leaving the net zero effort in the dust.
So would a given data center be dedicated just to AI, or might they be using it to host Netflix stuff, or might they be Bitcoin mining or just anything else other than AI?
There's some of each going on. And you're right, Bitcoin mining is another one that's a pretty big user of electricity. I know the Attorney General of Texas had complained about all the Bitcoin mining. I'm going to talk about Texas in a minute, but so there are a lot of things that are occurring and that are ramping up the need for power. And let's talk about some testified before on a Zoom video before the Senate of the Illinois legislature. Go to the next chart. And they were all talking about how they're going to build solar. They're going to build solar and batteries. Solar is about 1% of Illinois electricity. And I said to him, this isn't going to make any difference as far as emissions, what you do here in Illinois. Do you know that Texas is building 108 new gas-fired power plants, and they're expanding 17 existing ones? It's just astonishing what's going on. This is going to produce 58 gigawatts of capacity. Now, Texas is the biggest wind state in the United States. They have over 15,000 wind turbine towers. But when all these new gas plants are completed, they're going to use 3 times the electricity of all the wind turbines that have been built over the last 20 years. It's just really an astonishing amount of effort that's going in. And by the way, right now, it's very tough to get gas turbines for power plants. The waiting list is something like 5 years out from all these companies. So they're trying to expand capacity, these wind turbine companies, these gas turbine companies for gas power plants. So Meta Facebook, is building what they claim to be the biggest data center of the Western Hemisphere. They call this Hyperion. It's in a rural area in northeast Louisiana, and they've gotten the local utility to agree to build 3 on-site gas power plants. Now, this is the latest thing. This is called BYOP, Bring Your Own Power. Instead of relying on the grid, because there's not enough power in the grid, these data centers are putting in their own power plants right on site. And that's what Meta is doing. So this site, when it gets done in 5 years, is expected to use twice as much power as the city of New Orleans. You just imagine how big these things are. Anyway, so let's go on to the next one. So the environmental groups are saying, why can't wind and solar provide the electricity needed for data centers? And one of the problems with wind and solar is sort of captured in this chart. This data is in my recent book, Green Breakdown. And I got this from a scientist in Canada by the name of Vaclav Smil. And Mr. Smil has written an entire book on the footprint used by electrical power sources. Basically, he takes a look at how much land area is used to produce electrical power, and he includes everything. He includes pipelines, and he includes waste pits, and he includes mines for mining materials. And he finds that on the left, the average area to produce 1 unit of electricity, you can see there natural gas, nuclear, and coal. is about 1 unit of land, depending on what units you're using. But if you look over on the right and you look at the renewables, to produce 1 average unit of electricity, solar requires more than 100 times as much land as nuclear. Wind requires between 35 and 835 times as much land. And that's if you just count the concrete footpads and the roads, you get down to about 30 times as much land. But if you count the whole area, like that image on the bottom of that wind array in Scotland, it requires 800 times as much land as nuclear or coal or gas. Biomass, 1,500 times as much land. So if wind and solar if we didn't have the fear of man-made warming, wind and solar would be regarded as very environmentally unfriendly. It requires 100 times the land to produce the same average output. Now, this is a real example right here. 2 places in California, the Ivanpah Solar Facility on the left, and the Diablo Canyon Nuclear Plant on the right. The Ivanpah facility produces about 800 gigawatt hours a year. This is a kind of an engineering marvel. It was the biggest solar facility in the world in 2014 when they put it in. It has it takes roughly 5 or 6 square miles of land, 3,500 acres. It has more than almost 200,000 mirrors that shine light up on these towers, heat a fluid, and create electricity. But it takes 3,500 acres, produces 793 gigawatt hours a year. On the right is the nuclear plant that produces 16,000 gigawatt hours a year on less land, 750 acres. And there's the ratio. The nuclear plant produces 20 times the output on 1/5 of the land. By the way, it was recently announced that Ivanpah is being closed because after only 10 years, and normally these things have a lifetime of 20 to 25 years, it's just not producing enough electricity. It's expensive to maintain. It's out in the desert, and there's a lot of dust in the desert, and they have to have these crews going around continuously cleaning the dust off 200,000 mirrors, and it's just, fairly expensive. There's another problem with Ivanpah. It's one of the biggest bird killers in the world. It's estimated that it kills about 6,000 birds a year. When birds fly close to these towers, the heat is very intense, and they literally start smoking. And so they have a word for this. They call this streamers. When a bird flies close to the towers, it starts smoking and then falls to earth. Kind of a sad situation, but that's what it is. Anyway, just an example of how solar takes far more land than a traditional power plant. So what this means is, if you're going to put in wind and solar, not only do you have to go find land, which is scattered all over the landscape, it's in farmland, it's up on ridges, or it's somewhere. You've got to put together all these wide areas to equal the same thing as one power plant. But then you have to build transmission to all these places as well. You have to build all these towers, big transmission towers, which nobody likes, and build them all over to try and connect up all this wind and solar. You need 2 or 3 times as much transmission. And so that's just one of the reasons why this is very, very expensive to try and power data centers and our economy as a whole. So here's an interesting example. Now Tesla, Elon Musk's Tesla, is a huge electric vehicle manufacturer, but they're also a big solar provider and a big battery provider. But they went into the artificial intelligence business as well, and they built what they call their Colossus XAI near Memphis. They acquired 200,000 NVIDIA graphics processing units. NVIDIA is the company that makes the ICs and the processors that go into these data centers. But to power this system, they didn't use solar and they didn't use batteries. Instead, they got 35 on-site gas turbines because they could do it a lot faster. They built this facility in only about 6 months. They didn't even have the permits. They had people in Tennessee suing them because they didn't have the environmental permits. They put this system up in less than a year. Really just an amazing story. But again, not powered with renewables, powered with gas. Now, the other thing that's going on, of course, is what I call the Trump administration upheaval. Mr. Trump is not a big fan of wind and solar. He's complained many times about his golf courses in Scotland, where they have these wind turbine towers all around his golf courses. He thinks they're terrible and doesn't like them. But since he has come in, he's signed all these executive orders, basically halting offshore wind. And then Congress passed the One Big Beautiful Bill this summer and has cut all the tax credits and subsidies for wind and solar. Wind and solar had a 30% investment tax credit or a production tax credit that was equivalent. Those have all been cut right now. And so this makes it much tougher to go out and justify wind and solar projects. He also, of course, pulled out of the Paris Climate Agreement for the second time. But then, again, just a big pushback against net zero and a bit against wind and solar in favor of traditional power sources. Now, the proponents of net zero and of wind and solar say, well, we can use these big batteries, grid-scale batteries, to back up wind and solar. In addition to the land area, a big problem with wind and solar is that they're intermittent. Wind, on average, provides about 30% of its output of its rated capacity, and solar provides 15 or 20%, much less. And if you have clouds fly over your solar system, you don't get output. If the wind's not blowing, you don't get output. In the winter, you have snow covering. I have this one picture I didn't provide for you, but it's a great picture of a young woman in the United Kingdom with a broom. She's sweeping the snow off the solar cells in the middle of the winter. So the intermittency is a problem with wind and solar, and the proponents of wind and solar and net zero say, well, we know how to fix that. We go and use grid-scale batteries. And the idea here is you would hook up these big batteries, and when wind and solar are generating excess electricity, you'd store in the batteries. And when they're not generating electricity, you would have the batteries send the power back out and help solve that intermittency problem. Sounds like a good idea. The problem is that batteries are very, very expensive for long-term storage. Now, the numbers I'm going to use here are from the National Renewable Electricity Laboratory. To put in a system that provides about a megawatt of power with solar requires about $1 million. But to back up that solar for just 4 hours in a battery, the batteries would require $1.5 million. Now, a 4-hour backup is nothing. If you want to replace coal or natural gas, you need backup for a day or more. So for a 24-hour backup of a $1 million solar system, you would require $9 million in batteries. Oh, and then the batteries only live for half the life of the solar. Batteries live about 10 or 12 years, while solar is 20 to 25 years. So the bottom line is that to back up a solar system, you need batteries that cost more than 10 times as much as the solar itself. And the numbers are really, really very, very large. And now batteries can help in a grid. You can put them on for short-term fluctuations, and they can help ride over those and do pretty well. But for long-term storage, they're really not going to work. You can't use it to replace coal and gas or nuclear, and you really can't do it to run data centers. Data centers have to run 24 hours a day, 7 days a week. They work weeks on end to solve these problems and try and make machines think like humans. And so wind and solar really are very inadequate. And then there's this other problem. So we have a rising number of grid battery fires around the country. In February, one of the biggest battery systems in the world caught fire at Moss Landing, California. And it was 40% of that facility was destroyed. These batteries, if they get wet, they have to be kind of waterproofed. If they get wet, they can self-ignite. There's so much energy in them, and they tend to be unstable. And when these things ignite, they put all kinds of toxic gas into the air. People are told to leave their homes or close their windows. They close schools and roads. It's not a good problem. Over on the right is a picture of the Otay system, Otay Mesa system in San Diego. That had a fire last year. That thing burned for about 7 days. They kept putting it out, and it would reignite. And so the local residents were called back, sent away from their homes and called back, a real big problem. The state of New York is also trying to put in batteries, bottom left. There have been 3 fires in the state of New York in the last year. And then on the bottom right is a picture of the battery recycling plant in Fredericktown, Missouri, which burned up. Once these batteries are used up, they hope to recycle them. But then, they're kind of unstable. They've been used, and we've had battery fires. We've had 3 of them in Scotland. We've had them in France, Australia, in the United States in the last few years. And by the way, these battery facilities are not very old. All of these are less than 3 or 4 years old. So when you have a facility and it burns up, just not a real good system. But these are still being pushed by a number of states, California and New York, to try and go with the wind and solar. Just not a bad, not a good thing if you live near one of these facilities. Now, one of the biggest things going on is this company called OpenAI. They started as a research group, and they did the ChatGPT initial software. But they're building data centers all over the world. They call these Stargate data centers. They're building them in the U.S. and India, Norway, the Middle East, other locations. A couple of weeks ago, NVIDIA announced they were going to invest $100 billion in OpenAI. And OpenAI wants to spend $1 trillion on data centers next year. These numbers, this is more than the GNP of a lot of countries. The numbers are just astronomical. I don't know that they can really do this. I think maybe this is going to be pulled back at some point, but the numbers are just staggering. And the numbers they're talking about are amounts that are using more power than New York City for the accumulation of these facilities. Just really a really big thing. And so the idea that, again, we could power these with wind and solar just doesn't make a lot of sense. So Europe is sort of a latecomer, but they decided in this last year that they're going to get into artificial intelligence. And now, for more than 25 years, Europe has enacted policies to try and reduce greenhouse gas emissions. The European Green Deal of 2019 has a goal to, quote, make Europe the first, quote, climate neutral continent. They also passed the European Climate Law in 2021 that called for a 55% reduction in greenhouse gas emissions by 2030 and achieving net zero emissions by 2050. And so the nations of Europe have been installing wind and solar across the continent for many, many years. And about a third of Europe's electricity now comes from these renewables, a very high amount. But they all decide they want to do artificial intelligence now. So French President Emmanuel Macron announced in February he was going to spend over 100 billion euros to boost artificial intelligence in France. And he was arguing that his plan was comparable to OpenAI's Stargate plan in the United States that President Donald Trump has endorsed. He points out that France is the largest electricity exporter in Western Europe, which is true. And they still have this fleet of power plants. But, it's possible he doesn't understand how big these numbers are. I talked about the Hyperion Meta data center in northern Louisiana. When that's completed in 2030, it's going to use about as much power as 2/3 of the city of Paris. And by the way, France really needs a little more electricity. This Le Pen of the Conservative Opposition Party announced that as part of her plan, she's going to install air conditioning across France if she's elected. About 3/4 of French buildings do not have air conditioning. Many schools and hospitals don't. And in addition, over the last 20 years, the amount of electricity that's being used per person in France is down 16%. So the people of France are already not using much electricity, and now Emmanuel Macron wants to go AI. Same thing in Germany. Chancellor Angela Merkel closed more than 30 power plants in Germany. Germany used to export electricity. Now they're an importer of electricity from Norway. But the current chancellor, Friedrich Merz, says he's going to provide subsidies for construction of data centers. But the per-person power consumption in Germany is down 19% since 2005, more than France. But England takes the cake. UK Prime Minister Keir Starmer recently stated that artificial intelligence can create, quote, a better future. And so he's going to fund AI as well. But the United Kingdom is one of the places in the world that's heading towards zero electricity. The average person in the United Kingdom consumes 33% electricity than they did in 2005. And this is because of net zero. The prices have gotten so high, people are using less. And also manufacturing has been moving out of the United Kingdom, which is reducing the amount of electricity they're using. So something is going to have to go here in Europe. They're not going to be able to do artificial intelligence or the huge ramp up in electricity that's needed and keep net zero. It's just going to disappear. Okay, let's talk a little bit about COP30. COP30 is the United Nations Climate Conference, which begins next week in Belém, Brazil. And they're already having early meetings. De Silva, I believe his name is the president of Brazil, and he's holding meetings with top world leaders. But you know, if you look back and say, okay, we're now 10 years down the road from the Paris Climate Accords in 2015, how has the world been doing? And the answer is the world isn't doing very well as far as net zero. Let's go on to the next slide. This is a plot of data from Energy Institute. And Energy Institute points out that we're still getting 87% of our power globally from hydrocarbon fuels. That's from coal, oil, and natural gas. And this is because, in spite of the fact that we're now on COP30, the 30th meeting of the parties of the United Nations climate conferences. We have more than 400,000 wind turbines installed worldwide. We're just not getting there very, very fast. This is what I call the energy mountain. Again, this is data from the Energy Institute. This black mountain shows that global energy consumption has increased by about a factor of 4 since 1965. And except for the recession years of 2012 and the COVID year of 2020, this goes up every single year. Every year the world adds more than a United Kingdom new amount of energy demand. And I plotted down on the bottom the amount that is wind and solar down there. Those two little red and yellow ramps there. We have not, except for 2020, we've not had a single year when renewables have provided more than the increase globally. The amount of energy required is going up every year more than the renewables can add. And a lot of people don't know that today we have, again, this is something I told Illinois the state of Illinois when I testified before their Senate committee. There are 6,500 coal-fired power plants across the world today, and another 1,000 are in production. Coal is the biggest source of world electricity, providing 35% of the world electricity. Yet we still have 700 million people that don't have access to electric power. And there are another 2 billion people that have blackouts or brownouts every day or every other day. And we also have a third of the world's population that doesn't really have access to fresh water. I don't know if you saw, just a week ago, we had Bill Gates, the founder of Microsoft, and a climate fighter for many, many years, came out and said that, matter of fact, he sent a 20-page memo to COP30 saying that the world should shift from carbon dioxide emissions to relieving human suffering. And this is really a big change. He has, his organizations and his foundations have contributed billions of dollars over the last 10 or 15 years to fighting climate change. And now he says we should make removal of poverty and the benefit of people the higher priority in carbon dioxide emissions, which many of us have been saying for many years. So that's really a big, big change with Mr. Gates. It's been all over the paper. Many, many people have probably seen this. So I would encourage people to go get a copy of my book, Green Breakdown, The Coming Renewable Energy Failure. I finished this in 2023. The book is a complete discussion of energy, power plants, home appliances, electric vehicles, heavy industry, heavy transportation, and talks about how we're not going to get to net zero by 2050, how we're going to continue to use hydrocarbons to a big extent. Green energy action means higher energy prices, electricity blackouts, less freedom because they want to take away your gasoline car and your gas stove. And then these transnational energy shocks that we just saw in May, for example, in Spain, where 50 million people lost electric power within a minute or so. So people are going to demand a return to low-cost, reliable energy instead of this push for renewables. This is the one I want people to picture in their mind. Picture there of a huge tidal wave, 70 or 80 feet tall or something, and I call that the artificial intelligence revolution. And that little sailboat at the bottom, that is net zero energy policies. And this is what's going to happen. That wave is just going to roll over net zero and make it disappear, and we're going to get back to sensible policy. By the way, all of my books are very readable. I have another one called The Mad World of Climatism. And that's a great thing for if you have kids or cousins or nephews or grandkids in high school or college. They're getting a very one-sided point of view on climate. They should go look for The Mad World of Climatism. All my books, or my latest ones, are color paperbacks. And in addition to the science and economics, they have all these color sidebars, which are real headlines. You can go on to the next slide, which are real headlines that come from the press. Here's one that's crazy. Utah school gives kids disgusting insects to eat in class for climate assignment on cows killing the earth. This is a real situation. This was a teacher in, I think in Utah at a junior high who brought insects in for kids to eat for class. But it's filled with all these crazy headlines, and they're far beyond common sense, and they're amusing, but it's unfortunate because they really are raising prices for people wherever green policies are being deployed. Anyway, that's pretty much the summary of my discussion. Tom, I can go in other areas if you want to ask about those things, but we're going to see this artificial intelligence revolution take precedent, and net zero is slowly going to fade away.
Do you think that the whole AI revolution, that's the big reason why Bill Gates changed his mind on climate? Any ideas?
No, I think Mr. Gates is he's a sensible guy eventually, but he's been under a lot of pressure, and he's trying to do the right thing. But I think he sees that the oceans are rising the same as they have in the past. They're not accelerating. We've had warmer times in the past than today. And by the way, warm climates are better for people. If you look at the numbers, more people get sick and die in the winter than in the summer in every nation of the world. We had more COVID cases during the cold months than the warm months. Our flu seasons are all in the cold months. Warm temperatures are better for society. We're not seeing more hurricanes and stronger hurricanes and storms if you really look at the data and analyze it. And there are so many issues. Like Mr. Gates says, we have several million people die every year from disease. Those things need to be fixed. Adaptation is really the only sensible policy for climate change is adaptation. The idea that we can control or mitigate the climate, that is really not something we could do, except, maybe on a local scale, if we cut down all the forests or something, which may or may not be good. By the way, in addition to Mr. Gates, I should mention a couple other situations. We now have 3 major political parties across the world that are stepping back from net zero. We have the let's see, what is it in the UK? I can't remember what the car. Nigel Farage heads up the party.
Reform, maybe? Is it Reform?
Yeah, Reform UK. Thank you very much. They've coined the phrase "net stupid zero." In Germany, we have the Alternative for Deutschland, the second largest party, and in their plank, they want to get rid of all wind turbine towers. There are 30,000 wind turbines in Germany. It's like the highest density in the world. They want to get rid of all those. And then we just had the Nationals a week ago come out in Australia saying we don't want to do net zero anymore. We think it's too expensive. So there are some major things underway, and a lot of people pushing back. In addition to Mr. Gates.
So do you think that there's a chance that this AI thing is just a huge bubble that's going to pop sometime soon? People on Twitter are talking about new facilities that are maybe hundreds of football fields in size, and all that equipment is going to be depreciating on day one. Any thoughts?
Yeah, I know. You wonder how they can do it. How can you spend $1 trillion in that OpenAI wants to do and get your return on that? So yeah, there's going to be a revision on all this and a retrenchment, but the numbers are very, very big. But right so far, Microsoft and Meta and Amazon and Google are all saying they're going to increase their investment next year because they're seeing some returns here. By the way, the web is being impacted. The internet is being impacted. A lot of companies that have been revising on the number have been relying on the number of clicks on their websites are seeing that those clicks are falling off. It appears that people are looking at the AI answer they're getting when they do a search with Google, and they're taking that rather than going and doing research as they did in the past in a number of websites. So there are some big changes underway. Will there be a pullback? I think there will at some point. The numbers are just so astronomical, but the world is changing for better or worse.
Do you have any thoughts on whether the EV revolution is real and that's going to cause a lot of additional electrical demand in the next 10 years?
Yeah, that's another factor. It's not only AI, as you say, there are several factors that are causing demand. One is a push to shift to electric vehicles. Another is a push to shift to electric appliances. In New England, for example, they've talking about moving to heat pumps instead of gas stoves, and they say that will be more electricity than shift to electric vehicles. And then we also have we have had governments trying to push for a thing called green hydrogen for industry, which requires vast amounts of electricity. But those things are fading a little bit. The green hydrogen funding in the U.S. is being withdrawn. Hydrogen is having a big problem across the world. For example, the filling stations are closing in Europe now. They're closing in California for hydrogen. So there are these other factors. I haven't talked much about EVs. EVs are penetrating world markets. Last year, there were about 18% of world markets, new light vehicles sold are EVs. In the U.S., it was about 7 or 8%. But they're running into some problems now. In the United States, for example, the share fell from about 7% last winter down to about 6% in the summer. 6% of new cars sold, and that was before they canceled all the tax credits. The one big beautiful bill has cut out all the tax credits on new sold EVs and used sold EVs, so that's going to hurt the market as well. EVs are going to get better and better. They're going to solve their problems. I estimate they're going to be about 20% of the global market. They're about 3% today. About 3% of the light vehicles on the road globally are electric. That's at the end of 2024. That's going to continue to grow, but I think it's going to be about 20% by 2050, not 70 or 80 or 90%, as some people say.
Are you including hybrid vehicles there, or that's just pure EVs in those numbers?
Those are pure EVs. Hybrids add an additional amount. I think hybrids can be a pretty good deal. Actually, you get the long range with the gasoline portion, and then the electric portion gives you the good gas mileage. So I think hybrids are sensible, but they do cost more. You got a couple different engines in there. The other problem with these is, I think that the folks that wanted a cool Tesla for a second car, they got it. That's pretty good. But if you're in an apartment and you got to try and stretch a power cord across a public walkway, that doesn't work too well. So they're gonna take world share, but I don't think we're gonna go all to EVs. It's going to be a mixed future.
Do you have ideas on government regulation to try to reduce demand for electricity? Like I think in Europe, they were mandating crappier vacuum cleaners and maybe light bulbs that or banning real light bulbs. Do those make much of a difference in the big picture?
Well, I think they can make a difference. Yeah, they've been putting a lot of efficiency restrictions on various things, Energy Star and that sort of thing in the U.S. The Trump administration is rolling all that back now on refrigerators, appliances, and all those sorts of things. So it's going to change in the U.S. Again, I think the problem is a forced mandate is the problem. I think it's great to have people put up what their efficiencies are, and if people want to choose it, that's great. But this idea that to force everybody to buy an electric car, for example, to stop the oceans from rising, that's just a faulty idea. That there's no evidence that is what would occur. So we need to get back to where people can have the choices. They can choose an EV if they want. They can choose a heat pump if they want, or they can have traditional energy sources.
How about the rolling out of smart meters? Do you think that can affect things a lot, where people are not allowed to use as much AC as they want during times of high demand? In the big picture, does that make much difference?
Again, I don't buy that as a good policy. I think if I'm an electric company, I'd be trying to promote the use of electricity. That's my product, and it's okay if it helps you balance demand, I guess, and reduce your capital investment, the number of plants you have to have. But to force people to use electricity, I don't think that's really good policy. And again, there's no evidence that the storms are going to be less severe if we force everybody to use less electricity.
I 100% agree with that. So any other points you want to make before we finish this one up here?
No, not too much. I think that's pretty much it. It's going to be an interesting future here. Mr. Trump went before the United Nations about a month ago and said this whole thing is crazy. And we call it a scam or a few other things. He's really very outspoken, but we'll see what happens in the future. Again, adaptation is the proper policy. Netherlands for years was built seawalls and islands to help stop against sea level rise. If you want to stop hurricane damage in the Caribbean, you need to get the income of nations and people up, build very strong concrete buildings, not think you can put up wind turbines and solve it. In Central Africa, we have 40% of the people don't even have an electric fan. We need to get those people energy. We need to raise their levels of wealth, and they'll be able to adapt to the climate better than these other policies. But anyway, hope everybody will enjoy and take a look at my books.
All right, Steve Goreham, thanks a lot. I love your focus on numbers and logic and reality. It's great stuff. Thank you.
Well, thank you, Tom. Great to join.